You're listening to the Futures Podcast with me, Luke Robert Mason. On this episode, I speak to founder of NEO.LIFE, Jane Metcalfe.
We don't have a strategic plan. We don't have a creative brief. You know, if you were to set about designing the next stage of our species, what would it look like? And if that's what we want, what should we be doing today that'll get us there?
Jane shared her thoughts on the possibilities offered by the Neobiological Revolution, how digital technology is changing how we understand and engineer biology, and the important role bioartists play in helping us to navigate the ethical implications of new innovations. My own interest in the Neobiological Revolution begins about a decade ago when I met a man with an ear in his arm. And Jane, I did what most people would do on meeting a man with an ear in the arm. I asked him, why? Why do you have an ear in your arm? And that man, who's familiar to both of us, is an Australian performance artist called Stellark. And I remember him looking me deep in the eyes and going, well, why not? And the odd thing about Stellark is that he continued by explaining how we live in an age of circulating flesh, which sounded completely odd, but completely expected for a man with an ear in his arm. But what he meant was, for example, we live in an age of amazing biotechnology where my blood could quite literally be flowing through your body tomorrow, Jane, or your organs could be inside of my body if, for example, we were the same blood type, or if you were an organ donor and I was organ donor compatible with you. And what Stellark was really doing by putting that ear in his arm was showing us that we had a failure of imagination, that we have all of this biotechnology available to us, and yet the sorts of interventions we choose to do are making our cheekbones slightly higher, our lips slightly thinner, our breasts slightly larger, and we base it solely on cultural tropes of beauty. And what Stellark was showing was that these technologies are available, so therefore, why not have an ear in your arm? And I've always felt that it's the artists who play such an important role in helping us understand how we can push the boundaries of biology. So, Jane, what's your relationship with the artists who are doing this, and what do you think their importance is in how they look at this thing called the Neobiological Revolution?
Oh, what a great question. I think the role of an artist when new technologies roll out is to ask unreasonable questions and to push it to do things that the creators of the technology generally never imagined. For instance, if you look back at AT&T Bell Labs before they were AT&T, back in the 50s, had this fabulous series of collaborations with artists. And so many interesting technologies and ideas came out of that, like video teleconferencing, where they literally put a dining room table up against a wall in New Jersey and another dining room table up against a wall in Los Angeles and opened a video connection and had a Thanksgiving dinner. This was back in the 50s or 60s. It's that kind of, like, why are you doing this? Why would you ever want to do that? Sort of thing has been like a really important question that artists ask. I remember an artist who'd had, I think she was in a car wreck or motorcycle wreck, and she had some kind of concussion or brain trauma. She was demanding to get her MRIs, which were at the time not accessible to a typical consumer, and then use those to create art about the brain and about imagination and about getting how knock on the head, change things, about her own mortality. And she was just riffing off this stuff. And the technicians are like, no, this is our property. So it's so interesting to see how often artists are forcing the technology developers to consider something in a completely new light. I think that's why artists are important. Engineers are supposed to be solving problems, and that's not an artist's role typically. I mean, I hate it when I make these grand sweeping statements like this. I used to have this juxtaposition between artists and entrepreneurs. Artists get to ask questions, entrepreneurs have to have answers. I did have that conversation recently with an artist who said, I don't want to be responsible for asking the questions, I want to make beautiful art. But I do think that collaboration that takes us out of our everyday life, that takes us out of the paradigms that led to the creation of a particular product or particular capability, because you're already busy dreaming up something that doesn't exist. Sometimes it takes another out-of-the-box thinker to push it in a completely different direction. I also think art is a great way to meet people. And if you put art in front of a pharmaceutical executive, you might change the way that person thinks. And I think that's really important. I think there's a big opportunity there. And that's, I think, to me, what's so important for it within the context of the Neobiological Revolution.
Have there been any artists working in the biology space that have really inspired you or opened your mind to understanding really what's possible from this new form of biotechnology?
I think you kind of started with the big honcho in terms of that. I mean,
he's going to love being called the big honcho by you, Jane.
Well, I first met him in the late 80s at a SIGGRAPH conference, which is a special interest group of the Computer Graphics Association. And we were in North Holland, and he may have been naked. May have been wearing a little skimpy something or other, but otherwise he was completely wired up. And I believe he had his robotic third arm that's there. He had laser beams that were casting all over the room. He'd hooked it up to his heart rate and to some metabolic thing that was tracking his digestion. And all these things are generating sound, music, sound. And I thought I was going to an academic conference. So that was my introduction to all this kind of stuff. I mean, both how the digital revolution was going to happen and how the neobiological revolution was going to happen. So Stelarc remains obviously extremely provocative and extremely, I don't know what you call it, when you put hooks in your skin and hang from those hooks.
Suspension works.
Suspension works. Yeah, exactly. So he's been involved in that whole. There's far less exotic ways of expressing some of this. And one of my favorites is Heather Dewey Hagborg.
Of course.
She's very good at posing questions. And, years ago, she was already a biohacker, and she was picking up cigarette butts and chewing gum and sequencing that, and then coming up with profiles of what the people whose DNA she had found might look like. And ultimately, she connected with Chelsea Manning and created this fabulous piece that had multiple masks of what Chelsea Manning might look like as a man, as a woman, different ethnicities and so forth. We are not genetically determined. The determinism of our genes may be fatal in terms of, monogenetic diseases, but there's nothing that preordains who we are, how we express ourselves in the world. And so her work really kind of preceded at least broad societal recognition of gender fluidity and gender dysmorphia and dysphoria and that sort of things. So I think she's certainly one to look at, but there's so many. There's just so many.
Well, you mentioned a wonderful word there, genetic determinism. And it does feel like that your work prods and pokes at the idea that we're not genetically determined. By realizing that, it's opened up such a play space through which we can explore a multitude of possibilities for what it could mean to be human. And you frame that in the context of this thing called the Neobiological Revolution. And we're going to mention that multiple times on this podcast. So for our audience, what is the hashtag Neobiological Revolution, and probably title of the show? But for our audience, what does that mean?
Well, I think it's obvious, but everybody keeps asking me this question. So I guess I need to explain it to a broader audience. I hate replaying the tape, sort of, because 30 years ago, we started Wired Magazine and we were talking about the digital revolution. And in our minds, that was going to and did, transform the way we do business and the way we educate our children and our entertainment and our communications and the financial markets and ultimately, our civic institutions. And it really transformed all of these external structures in our world on a global basis. And we had children right around the time just before 2000, so late 90s. And we were able to watch our children basically grow up and live through what I considered the digital revolution. What happens when you get broadband and everybody's got access and there's multimedia online and thousands of channels and all that sort of thing and multiple communities coming online and access to all the world's information and so forth. And now my kids are out of college, and maybe this is empty nester syndrome or something, but to me, this is like closed a chapter. There was a time about 5 years ago when I was really hatching this idea where innovation in Silicon Valley had been so directed towards social media. And to me, that just felt like a dead end. It just felt, it's a thing, but it's an eddy. It's kind of a holding chamber. Maybe it's purgatory. Maybe it's hell. Maybe it's just flat out hell. But I didn't really want to engage with that. I wasn't really interested in that. And, at the time I was experiencing some familial medical issues around mental health and cognitive decline. I just had this moment of realizing that the next revolution is not these external structures. That plays out. We kind of know what that pattern looks like. We know what the disruption cycle is and so forth. And, we can see quantitative computing and artificial intelligence and robotics, and we can sort of map that out. But to me, what was really interesting was turning that engineering mindset to our own bodies, to our internal biology, to humans' evolution, really. And CRISPR had just been discovered, announced, patented, all that sort of thing was going on. And just as we got started, He Jiankui edited the two children, genetically edited the two embryos, ostensibly to prevent them from inheriting HIV from their father, but ultimately also tweaking this gene that has been implicated in learning and cognitive performance. That's a lot of power. I haven't seen that kind of newly unleashed power since the beginning of the digital revolution. And it's new biology enabled by big data visualization systems, like new imaging capabilities. We can now see at the resolution of an individual neuron. And we can see whole new biological systems that we didn't even know exist or understand how they functioned. And that's just on the imaging side. There's the genetic engineering side. And, it's just all of this stuff was exploding. And to me, it was like, it's a brave new world. And one of our former collaborators and friends, John Perry Barlow, wrote a very famous Declaration of the Independence of Cyberspace. And I sort of thought, we need a manifesto like that, because there's a whole new world. And it's uncharted, it's unregulated, it's terrifying and thrilling. And to me, as a journalist, it's the story of our times, I think. 25 years later, I'm like looking at another story of our times. So that's kind of an amazing thing.
But it does feel like that when we talk about biology, we kind of separate it from digital technology. It reminds me of Rudy Rucker's idea of there's software, there's hardware, there's wetwares, there's kind of a hierarchy of these things. But in actual fact, the Neobiological Revolution, it's about integrating a convergence of different technologies, isn't it? Some of those being digital technologies, as you just mentioned there, imaging technologies, sensors, the ability to do genome sequencing. So in what way does the way in which we're thinking about biology today have the similarities to the way in which we've been thinking about digital technology? Or in actual fact, do we have to think about biology in a completely different way?
Yeah, I think what's interesting is, you have 7 layers of skin. Your derma is 7 layers thick. It's like when you're looking at biology, it's so many layers of depth. You first learn it in 5th grade, here are your body parts. In 7th grade, you revisit it. These are the major systems of the body. 9th grade, and then you have to do physics and calculus and chemistry. And then you can come back to biology. And there's so many different levels at which we understand the body. There's the signalome. What are the electric signals within the body that we can capture, and what are they telling us? There's the metabolome. What are the chemical processes that are taking place in your body that break down your energy sources and distribute that energy out to your cells? There's danger in trying to consider the biology from a purely digital standpoint, but it's because there's many layers to this. It's a cube and you need to turn it over, or maybe it's an octagon. I don't know how many sides it has, but with biology, you have to be constantly turning it over again and looking at it from another point of view. And, it is the ultimate complex system. And so, the more data we can gather, the better we can start to understand how these systems interact with each other. But it's messy. They call it a wet lab for a reason. And people toil in obscurity for their entire careers trying to make something live. And they have to go back to the lab. I mean, I have dinner parties and people are like, gotta go, I gotta do another feeding, or I gotta check on my cell line, or, whatever it is. It's not just punch in the patch to my code and hit execute, go out for dinner. these processes are very different. There's different mentalities, there's different language, there's different rhythms, and it's really interesting. I was thinking about an early collaboration between Genentech and Google, and one of the people involved on the Genentech side was saying, they just don't get it. And that's typically what happens is people come into this wet space with their Silicon Valley, we can do anything kind of attitude, and are schooled in why this is different. And it's the process is different. The underlying cells are not bits, but it's also the institutions, right? I mean, Silicon Valley is famously a risk tolerant, and let's just try and let's just see what happens. And in the life sciences, you've got an institutional review board that considers the ethics of what you're doing. There's the process of what you're doing. Then there's the reagents required to do what you're doing. Then there's the actual ability to do what you're doing. And it's just like, moves much more slowly, much more risk.
Do you think we should take a more proactionary approach to some of these things and allow some of the regulation to slip? Or should we look towards seasteading, for example, as a way to just go and do hyper-experimental drug trials in international waters? Or is this regulation highly important?
Yes.
Yes to all of the above. It's a difficult question, isn't it? I mean, I love the guys who argue for seasteading. And then we had Christopher Mason on the podcast recently who was like, forget seasteading, right. Space steading is the thing. Like, the only place where we're going to be able to justify the genetic manipulation of human beings is on Mars, because literally it will be a life and death situation up there. If you don't have the genetic modification, you ain't going to survive that environment, so you're going to have it, and therefore finally we have a true justification for actually manipulating human beings. So it might not be a terrestrial thing, it will be a thing that we'll have to do when we leave this planet.
Completely agree. He's amazing, and I think his work is super important. And all of this experimentation that's happening there with crops, with human biology, with animal biology, is so important. And I really wish more people could understand the benefits of our space exploration. It's true that we've already contaminated other planets with our bacteria. And that's kind of a frightening thought, like it's already too late, because beyond this idea of Homo sapiens as colonizers, going out and spreading our germs in ways that could potentially destroy other life forms, is this idea of just practicing on Mars or the moon is going to teach us so much about so many things, like not only how to save lives or extend lives or enhance lives on this planet, but how to grow food under drought conditions or with extreme radiation, or, real life scenarios that we can experience on this planet right now in this time frame. And so I think there's many, many benefits. And to the extent that we're doing it in space, it's a highly militarized environment. It's highly regimented, but it's also collaborative. I mean, the International Space Station, there's a lot of science being discovered and explored and shared. And so I kind of like the multilateralism that's been happening in space. And I wish that we could find mechanisms on Earth that were collaborative in the sense of not just scientists collaborating, because of course COVID's been this brilliant example of scientists collaborating and sharing and, let's all come together to solve an urgent problem. Like, great. Let's practice doing that on climate change. Let's practice doing that on human genome editing. We have these scientists who are collaborating. We haven't quite pulled in the policy people with the behavioral economists, with the ethicists, to have these kind of global conversations on matters of enormous import to the future of our planet, the future of our species. So just as we have to reach out across the biodigital divide, we have to reach out across the scientific, academic, industry, NGO, diplomacy divide as well. And that's getting back to art. I mean, that's another thing that artists can do so well.
Cross-disciplinary ways of doing this sort of research is going to become so important, because when it comes to biology versus digital technology, the unintended consequences could be so much more. The stakes are so much higher in many ways. Digital, it feels like it deals with ones and zeros, and these sorts of things can be to a degree predicted. But when it comes to biology, as you said earlier, biology is really difficult. It's really hard. And there's so many things that we just don't understand that we can't always model for. And if we don't take into consideration a multitude of unintended consequences that could occur down the line, we could end up in some very problematic spaces of exploration.
I was just at a dinner 2 nights ago with some AI luminaries, and they were talking about sort of the sense of the limits. Like, there's only so much we can do. So we get these data sets and we train our algorithms on these data sets, and then we put it out there, and whatever happens is just a reflection of our society. And this kind of not my problem attitude was kind of shocking to hear in Oakland in 2021.
Yeah.
A little dispiriting, I have to say. So the conversation kept going. It was like, the algorithms themselves are not evil in most cases. There's certainly a lot of unintended bias embedded in those algorithms. But what about the training sets?
Yeah.
So where is the data coming from? And, if you're basing your algorithm on 50 undergrads at Stanford, that may not be a reflection of our population at large. And I was just talking to a man in South Africa who's committed to sequencing 3 million African genomes, because that is the richest diversity of genetic material is on the African continent that hasn't been sequenced yet. And because of that, something like 2% of the entire diversity of the human genome has been sequenced. So already we're building lots of systems based on what we know of the human genome, but we're only looking at a tiny percentage of the entire diversity that's out there. And yet these become the foundations for many systems in healthcare, particularly, and biosciences. And how do those training sets then, what are the biases that get baked into that? And then how do we back that out again? And how do we flush the system with new data sets and train it again? And hopefully give a little ethical guidance along the way. Like, I wrote this in the intro to my newsletter on Thursday, and I'm just going through all of the people who responded and said, whose job is it?
Yeah.
And we don't know whose job it is.
That's deeply terrifying in many ways. that's deeply problematic.
Yeah,
the underlying ideology there, you keep mentioning the word systematizing. When we start looking at the human being as a system, as a form of machine, that really changes our relationship to the body. But when it comes to the development of some biotechnology, that's kind of the starting point. It's, well, the human being is a machine with problems that need to be solved. Do you think, Jane, we're kind of misselling the human in that circumstance? Do you think, in actual fact, we're leaving a lot of stuff in reserve by just looking at the human as some sort of machinic challenge that biotechnologists will use as the new frontier, as the new platform for new innovations in technology?
Oh, I love that question. I mean, I think the human biology as a reflection of like all life biology and a continuum of everything from a little tiny virus or bacteria or algae or fungus, all the way through the complexity and classes and kingdoms, up to Homo sapiens, and seeing us on a continuum with Earth as well and with the Earth systems. And my big hope is that we not model life based on digital and industrial practices. But what we do is use our industrial and digital capacity to understand what's already evolved over the course of time and how to channel that, how to harness that, how to mimic that. One of my favorite places on the planet is the Wyss Institute for Biologically Inspired Design at Harvard. I mean, they're just doing amazing work there where you get a cell from a jellyfish and you graft it or inject some of the DNA into stem cells. And then the stem cells start to pulse like jellyfish for propulsive systems, or you can do that with cardiac cells. It's like, how can you take things that we learn in nature and use them to enhance humans, to enhance other animals, to enhance plant-based botanical processes as well? So I'm kind of super interested in sort of chimeras and transgenic experiments, which I'm interested. I understand there's huge ethical implications there. But last week, they took a genetically modified pig and extracted the pig's thymus and kidney and grafted it onto a patient who unfortunately was diagnosed brain dead. And we're able to graft the thymus to protect the human body from rejecting the organ and the kidney. And they vascularized it and it functioned for 54 hours.
Wow.
So the idea that we could actually use pigs as incubators for organs is really getting much, much closer based on this experiment. And thanks to the family that allowed that experiment to happen, because as long as you're stuck in animal models, you're light years away from making this happen for humans. But the idea that people don't have to die for lack of a liver or kidney anymore would just be astonishing.
Do you think that if we get too excited about the biotechnological revolutions and things that we can do we fall into that tricky zone of only looking at what we can do? In other words, the whole thing around this sort of science is that just because we can doesn't necessarily mean that we should. And do you think there's some decisions that we need to make before we start exploring the limitations of what we can do through these new technologies?
Yeah, it's really difficult because I asked a very naive question to which I actually thought there was an answer. I said, okay, you guys have this godlike technology. Like, what are you building? What are you designing? How are you planning to change our species? And I'd like to hear it because presumably you have a vision for the future of our species because here you are tinkering with it. And people looked at me like, who's this batshit crazy woman? Just go away. We're just trying to solve this problem. And I realized that we needed a strategic plan.
Yeah.
We don't have a strategic plan. We don't have a creative brief. If you were to set about designing the next stage of our species, what would it look like? And if that's what we want, what should we be doing today that'll get us there?
Yeah.
And I still think that's kind of an interesting way to think about what we're doing. And I think it smacks of eugenics. And nobody wants to have that conversation. And so it's interesting who is willing to engage in that conversation and how do we frame this in a way that doesn't just throw us back 100 and some odd years to Mengelé's experiments in Germany or the early eugenicists in the United States. It's a really, really tricky challenge, which is why it's really easy to go talk about enabling astronauts to survive in space.
Yeah.
That's like, I keep coming back to that. And then how can we use that to cure disease on this planet? It's a little scary to realize that we need these guardrails, but I think we do. I adore iGEM. I don't know if you're familiar with this, but it's a competition that brings high school and college students together from around the world to do experiments in synthetic biology with a social purpose. So each project at each school has to have a benefit to humanity or the planet or both as its endpoint. And they've worked very, very hard on imbuing their process with ethics, with responsibility, with verification. So people don't go off in a lab and do some weird, super viral, super toxic pathogen that then gets released, or fire spewing robots or something. And so I think these are just really important frameworks and training grounds that we need.
I adore your enthusiasm when you talk about biology as a design tool, but it does open up all of those, I guess, problematic terms. You mentioned eugenics, but another one is the idea of intelligent design. If we're starting to have the technologies of gods, as your friend Stuart Brand says, we need to start becoming good at it. And the challenging thing with this, revisiting this idea of intelligent design and realizing that we could become intelligent designers, is that project plan or the lack of project plan. And we're unsure what to design for. But when it comes to asking these people, why do you think human beings have the right to become these intelligent designers, have the right to take control of their evolution? A lot of people go, well, that was nature's plan. Nature evolved human beings to give us intelligence, to generate biological tools, to then manipulate ourselves and take control of evolution. You sit there and go, hold on. So you're saying that the reason we can become intelligent designers is because there was some intelligently designed plan for us in the first place. And all of that confusion really comes down to one simple thing, which is, what is our relationship with nature? And Jane, what do you think our relationship with nature should be? Are we of nature? Are we separate from nature? And how does the way in which we consider ourselves in relationship with nature guide what we believe we can and we should do?
Sorry,
I need to write simpler questions.
I need a shot of whiskey for this one. But I do absolutely see us on a continuum.
Right.
And it's the opposable thumb. I know you had the women on who were putting an extra digit on their hands.
Yeah, of course.
You had so many amazing podcasts I wanted to listen to, and I was thinking about this. But it is in our nature to make tools. It is who we are. It is why we exist. It's how we have evolved. So I do pretty much subscribe to the concept of, this is an expression of who we are. Has there ever been a creature that did not do and continue doing the thing that enabled it to survive and evolve in the first place? So this is the way of nature. Things that don't survive, don't reproduce, don't exist anymore. Things that do survive, reproduce, and mutate into something else that is survivable. I mean, the manifest destiny, if you will, is to survive and reproduce. That's how we continue. And I know you've had guests on who think that we should interrupt that process. I'm not one of those. First of all, I don't think we're going to have as many humans as we fear. And secondly, I don't think our planet can't support them. I think our planet can't support them using our resources the way we currently do.
Yeah.
But I think biology shows us how to use those resources better. And biotechnology shows us how to get there faster.
Yeah.
So the idea that huge amounts of this country have been turned over to agriculture, to big agriculture, to monocrop agriculture, which then, of course, is more susceptible to disease and all the rest of it, and the fertilizers and the pesticides and that whole cycle. And now everything needs to be shipped from this big place where it's all made to the place where it's going to be eaten. We can disrupt that cycle in really exciting and interesting ways. Just doing what nature's already shown us can be done. And, fermenting the food in big vats that can be local to the population centers, or growing stuff ourselves. I mean, there's no reason why we can't be growing our own sprouts and our own lettuces and our own things, because that's hugely wasteful. I also think, of course, getting rid of all those cows, all that methane gas, all the land that they need, so that other large ruminants can roam that land and do what they do so well. So I'm a huge proponent of rewilding the planet, huge proponent of making food local, and thereby controlling a little bit more the nutritional values that we're looking for, so that people in Idaho don't have to eat potatoes in the winter, but, have access to other things. And people in the Sahara have access to fresh fruit and vegetables year round. So I do think that the answers are there.
Yeah.
And the more we study nature, the more we study biology, the more we will learn and the more we can pattern off of. Biologically inspired design is just brilliant.
The problem is that human hubris sits in between that. We go, hold on, we've got to understand the processes and the systems, and we've got to model and map those systems before we decide to do certain things. But as you just said there, rewilding, if we just give 50% of the planet back to nature, nature will do the rest. It's the biology will work it out. It's the Jurassic Park thing, it always finds a way. It will find a way to create the self-sustaining systems. I mean, there is that big mystery of why we even popped into existence in the first place. Why did planet Earth decide to stop at the perfect conditions to sustain life? There is something so wonderfully mysterious about biology that has generated and created these circumstances that we should approach it with some form of reverence. And I think the challenge has been that human beings have lived through certain environments where nature has seemed to be a challenge to them, but now we are apex predator and there are no things to come and affect us. And instead, what we end up doing is creating this era of the Anthropocene, where we start to see now that because we are on top of this food chain, we can change nature in whatever way we see fit. And it's dealing with that realization, which really comes, I think, to the core of your interest in your work, because it used to be that nature and the body would define humanity. But now we're at the point where humanity can define nature or the environment and the body. And that becomes a creative challenge for the very reason that you're talking about of there's so much we could do, isn't there, Jane?
There truly
so
is.
Where do we start?
Yeah, it can get so out there that I just keep coming back to disease.
Yeah.
And it just feels to me like we start by curing disease and preventing it from happening. And that's very grounding. That's something I think we can all buy into. We can all support. That provides us with a moral compass, that provides us with a sense of what's real and what's possible. The sticky part is differentiating between bringing somebody who is below a baseline of health to baseline and then enhancing beyond that baseline. And so this is often where these conversations get either grounded or stuck, depending on your point of view. Can you actually differentiate between curing and enhancing? Back to this CCR5 gene that the Chinese scientist, who by the way was not a biologist, so that's also part of what the big outcry was. He wasn't a biologist. He did not follow biological and medical norms for his experiment. But by making the tweak to the genome, preventing the girls from inheriting HIV, were they also leading into some form of cognitive enhancement? So we don't totally understand what one gene tweak will do, right? We think it will prevent HIV, but we also think it will enhance that. So are we allowed to prevent HIV? Yeah, but are we allowed to at the same, and it's the same edit. We'll have both outputs, both impacts, both endpoints, if you will. And then, there's the fact that we are not equal, right? I mean, you may have far greater lung capacity than I do. I may have far better eyesight than someone else. Somebody's taller, short, we're very, very diverse. And there isn't like one ideal Homo sapien. I used to think that everybody would want to be tall, blonde, and athletic and smart. But I had a gay housekeeper who told me, I like short, dark, hairy men. And I was like, great. I don't. So that's great that you do. And so I think he wants, if he and his partner had children, they would want a short, dark, hairy man result. I don't know. I'm supposing. But we see people in the deaf community who don't want to destroy an embryo that's at risk for deafness because they want to welcome a member into the deaf community. So I think the choices that we make here might be different from the choices we make in Nigeria, and that might be different from the choices we make in Bangalore or Beijing.
Well, then this becomes the crux of the fear when it comes to these sorts of biological interventions, which is it gives us choice. And those choices, those are made for certain reasons. We have to not question the underlying biological processes, but what we need to question is the societal frameworks which make us lean towards certain choices rather than others. Because you do have to think, what would the perfect human be for this current environment? Well, we spend most of our time surgically attached to our shiny glowing rectangles, so maybe a human with a hyperambidextrous thumb so they could text more would be ideal. We can come up with all these odd scenarios for the sorts of humans that are able to deal with screens and Twitter and social media and digital technology and the flow of that. But then the question becomes, why?
What if we created humans who can't do that? Maybe that's where we should go.
Well, but we have humans who can't do that, and they become artists because they're like, well, this social media thing is silly. Let's get off that and let's go for a walk instead. We need that diversity of human beings. We need folks who are able to deal with code and complexity and technology, but we also need humans that can deal with creativity. And in being told that we get to make the choice means that we become unstuck because we get choice paralysis more than anything else. If you got to decide what you would want to change about them, I'm not sure if you could even make that decision in an informed way.
Well, I think that's a really interesting question because more and more couples more and more women are freezing their eggs. More and more couples are freezing embryos. And if you had to choose which embryos to implant, wouldn't you want to do a pre-implantation genetic screening? And while you're at it, wouldn't you want to screen for height and IQ and forget eye color and whether your ear is attached or dangling. It's like there's a lot of things that we can search for. And what happens when everybody is now choosing their own child?
Yeah, we end up with a lack of neurodiversity, and then we end up accidentally removing good art.
Exactly.
We need neurodiverse people who may have horrible mental challenges, but some of the most tortured people in the world create the most beautiful, interesting, and engaging artwork. And the question becomes, how do we change our opinion of value when it comes to those sorts of questions? God, I'm sure there's artists who are in tortured mental states who would choose to not have to deal with that. But equally, would that quash their creativity? It's spoken about a lot with artists and actors who deal with bipolar disease. When they have to take the certain drugs to level them out, it just kills their creativity with their anxiety as well.
Well, and this is why schizophrenics won't take their drugs, right? Because they flatline. I know this from my family. It's a really big issue. I mean, would you sign up as a parent to raise a child that was at risk for mental illness?
Yes. But then my worry is less about how we manipulate humans and more about how those manipulations, the decisions about those manipulations are being made by what we value in society itself. And perhaps that's the thing that we should be more worried about. And it goes back, I guess, to what you originally were looking at 20 years ago, which was consumer technology. I mean, biology, it hasn't yet reached, there's a couple of small projects on the outliers, but it hasn't yet become a consumer-based thing. But God, when it does, that's going to really change how we think about it. So I'd be fascinated to sort of hear your insights into what you think about biology as consumer technology, how that's going to change our relationship to it when we pay for it, and how that also changes our excitement for it. Because the wonderful thing about Wired magazine is consumer technology, shiny glowing rectangle, it's in my pocket, yay. Whereas biology, it's like, how do I get one of these things? Or, how's that going to affect my life? What's the shiny thing that I can buy that does a biological thing?
The interesting thing to me is the overlap between like cryptocurrency people and longevity.
Yeah. Oh, they're fascinating. Yeah.
It's really interesting. I don't see people focusing so much on wanting to be taller or whatever. I think a lot of Silicon Valley's focus is on we're masters of the universe because we control all the technology, and the society has valued us now as the most powerful, the most influential, and rewarded us with great riches. So we'd like to live forever to enjoy this forever. Yeah. I do think that the longevity movement extends beyond that mentality. And the most interesting part of the longevity movement are the people who are focused on living a healthy lifespan up until the age of 120 or 130, which is the theoretical limit of a Homo sapien life. And I'm all for that. Why not? If we can be available to our great-great-grandchildren, if we can serve as the history that nobody teaches in school anymore, if we can be the conscience, I think that's really important. Just being my ripe old age, I've been able to see the new irrational exuberance that's happening in the Silicon Valley right now with just more money chasing. Somebody said you could put a piece of cardboard up and write artificial intelligence on it and get it funded. And it's pretty much true. I'm just shocked at the things that are getting funded. And if you had lived through that long ago .bomb era, you might be pulling back at this point. I think there will be a burgeoning market for fertility clinics that are promising you, smarter babies, more musical babies, more babies that match what we think society will value. But there's this whole other movement. I was talking to the the director general of the International Labor Organization. And when we're talking about long life, you live to be 75. And for 25 years, you got educated. And for 25 years, you worked. And for 25 years, you were like an old person. I'm exaggerating a little bit. Your work life was, let's say, 35 or maybe even 40 years. But that's the way your life was organized. And now we're looking at people living and having careers for 80 years. It sounds a little sad for a lot of people who don't have as exciting careers as you do, or as some of the Silicon Valley people, or some of even the medical people. It's, oh man, if I had 80 years to solve this problem, to cure this disease, I could do it. There are a lot of people for whom work is just hell, it's dispiriting, and it is not enhancing their lives in any way. It's what they merely do to bring home money to feed their family. So I think rethinking what our lives are worth and rethinking how we value ourselves comes along with all this technology.
Yeah.
And the technology, social media, like all that stuff, combined with, I think, upheavals in our sense of the capitalist system being so unregulated and so corrupt on so many different levels. I mean, I think that all of these ideas are sort of percolating at the same time. And it takes a pandemic, and I think it takes climate change, and it takes Black Lives Matter for us to kind of maybe see, plus all of this new capability, all this new technology that gives us these amazing powers, to create a perfect storm, which is a cauldron of new ideas and new thinking. And our globalism, our multilateralism, I think, are big opportunities to kind of start to think differently about things. And I think were we to have these technologies and march forward unchanged by them, it's very easy to see why the science fiction writers keep building the same world over and over again, right? Whether it's Gattaca or, I particularly love Neil Stevens. I have not read his new book, but in so many different sci-fi worlds, we try and pick the type of people we need so that we'll have a diverse society in the future. I think it's going to evolve. I don't know that we'll ever control it.
The wonderful thing about science fiction is it does make some of these ideas very tangible. And I always love the idea that The Matrix was 1999, and The Matrix was all about living inside of digital technology, living inside of a simulation. And exactly a decade later, in 2009, Avatar, James Cameron's Avatar, was released, which was a film about biotechnology. It was about big blue bits of biotechnology that you could port your consciousness into. And it opened the Overton window for us to think about, maybe biology is in actual fact the frontier here. And I've always felt like Pokemon, for example, is a great advert for chimeras. That has helped an entire generation open up to the idea that, hey, I can mash different animal hybrids together and create these incredible, odd and wonderful creatures. Is there any science fiction that you, Jane, have read or engaged with that you feel really captures the sort of neo-biological future that you hope will occur?
I think this might surprise you, but it is a perfect kind of recapitulation of our conversation. Richard Powers, The Overstory. He won a Pulitzer Prize for it.
Right.
And it's a story about trees. And it's a story about the relationship between trees and families and humans over time. And it's really beautifully crafted, beautifully written. And I thought, I want to know about oak trees. I want to know about chestnut trees. But it's only after you finish the book that you realize what he did there. And I saw what he did there. And it's brilliant. It's not science fiction, but I think it's inspiring.
Those inspiring stories that make us realize that nature is so much more complicated. You talk about trees and you realize we're always told that these kind of trees grow independently, but then we forget there's like fungi and mycelium and all of this interconnected ways of linking these trees up so that they can share resources. And we look at the internet and go, look what we built. And then you look at nature and you go, nah, they were doing that years ago, thousands of years ago. They worked out network maps. And it really does feel like that's at the core of your excitement about this neobiological evolution, because it's more than just talking about exciting forms of biotechnology that could be over the horizon that could soon be commercialized. And instead, it's more about looking at nature itself to find a way to live in greater harmony with the environment we find ourselves in. And in actual fact, should the things that we're looking at be less about startups and entrepreneurs who are using biology in the lab to create new things, and more about looking at indigenous cultures who found ways to live in relationship with nature and find out how we can integrate that into our knowledge of the world and engage with the world in a truly biological sense, to understand that, hey, nature might be the thing that's kind of got this right, and humans could do a good thing of paying attention to that.
Absolutely. I mean, I don't want to say less of this and more of that, but I do think it's one of the reasons why we cover sacred plants, sort of high in nutrient quality or high in its ability to change your consciousness or alter your depression patterns or whatever it may be, because there is a lot of ancient wisdom there that I think is really so interesting when we bring our scientists and biotech tools to that. They've been doing work with ibogaine to actually, which is supposed to be this completely mind-blowing psychedelic that always sounded like too scary for me to try. And now they've got a way of knocking out its action on the 5H2A receptor. So I probably have that wrong, but something along those lines, so that it is not actually psychotropic, that it still has the kind of impact on your consciousness, but without tripping. And I'm feeling sad about that.
Yeah, me too. You listen to folks like Julie Holland, and she talks about the rise of psychopharmaceuticals, where basically drug companies are trying to work out how to make these daily supplements, because the wonderful promise of psychedelics is, hey, you can do assisted therapy for 12 sessions and be cured. And the drug companies are looking at that going, no, daily doses, please.
Right.
And what they're doing is creating psychopharmaceuticals that extract the chemicals from the psychedelic so that you can have the chemical experience in hope that that will cure you. But what someone like Julie Holland is arguing, that no, in actual fact, it might not just be the chemicals that's curing you. Perhaps it's also the spiritual experience that has some form of curative or restorable properties. You have to go see the machine elves to be cured. You can't just take the chemicals and assume that the brain will change in the way that we've seen in these wonderful results.
Ego dissolution is so important for understanding how we're all connected. And that's maybe one of the ways nature has of showing us that. Yeah. On the other hand, treatment-resistant depression is one of the biggest risks to the future of our species, right? I mean, it kills more people than some very dangerous and awful diseases. It's a very common problem around the world, and it's only getting worse. So if you can't find the right set and setting, if you can't get over people's attitudes and mindsets, but you can give them something that relieves their depression, I can argue both sides of this, but I do believe that you are really losing a big opportunity. And I blame Timothy Leary on many levels, for having unleashed such a powerful backlash. On the other hand, he was there, and many people were there and experienced it at the times, and then put psychedelics on the shelf and never thought about him again. And now that it's coming back, it has an opportunity to connect the people who are actually in power right now, who are the baby boomers, with the next generation who are coming up. And that's really powerful. That's what Leary didn't have, right? Because he and his cohort were fighting against the man, the machine. And now the man, the machine is us. Yeah. So there is a big opportunity here for big change. Yeah, I think it's the most amazing time to be alive. Most incredible. Well,
that's very true. And Jane, there's so much I could talk with you about. I mean, almost every question feels like it could be a podcast in its own right in the way in which you've answered it. But I do have to ask you one final question, which is one of optimism, an optimism about the neobiological future. Because if you could play Bruce Sterling just for a second, if you could take that role of a science fiction author, in your mind, what is the most compelling vision for a future that's enabled by a neobiological approach to the way in which we think about humanity, nature, and the world?
I can go way out and think about the next iteration of our species with enhanced intelligence, enhanced empathy, with the ability to travel to different planets without getting cancer, the ability to, through travel to different planets, understand different ways of living, which to me is really, really, really interesting. That's kind of my ultimate long view of things, a place where we have become cyborgs. To me, it's inevitable that we move in that direction. But that's beyond my lifetime. Who's to say the Homo sapiens is the end of the line? We're not the end of evolution. We're just the top of the food chain right now. So I'm super excited about what our species can become. But within my lifetime, I think there's a lot of amazing sci-fi stuff that's going to happen. And I'm super excited about preventing disease. Yeah. We spend so much money and so much energy doing wrong things with bad outcomes. And it would be really obvious to disrupt our existing food systems and education systems and work systems in ways that would eliminate the $4 trillion that we spend on healthcare in the United States and provide a life worth living where you have access to clean food and clean water and are free from genetically inherited diseases and hopefully avoiding cancers, because we've figured out that prevention, whatever amount of money or energy or technology is required to prevent people from getting sick in the first place, will unleash untold amounts of creativity and wealth and innovation. I really think, my grandmother used to say this, if you don't have your health, you don't have anything. And I really believe that. I really think that's true. And so being free of disease, that to me is a pretty cool future.
And on that wonderfully optimistic note, Jane Metcalfe, thank you for being a guest on the Futures podcast.
Thanks for having me.
Thank you to Jane for showing us the potential power of the Neobiological Revolution. You can find out more by visiting www.neo.life, where I've recently contributed to a list of 36 biologically inspired gifts for the holidays. If you like what you've heard, then you can subscribe for our latest episode, or follow us on Twitter, Facebook, or Instagram @Futures Podcast. More episodes, transcripts, and show notes can be found at futurespodcast.net. Thank you for listening to the Futures Podcast.